Hi everybody, solving paper 2 November 2019. Figure shows pyramids. Why pyramids are very stable, have a wide base. Largest stone has mass. What weight? Fg 9.8. Weight equal mass times G. Answer will be figure shows wooden beam being used to lift a stone block. Wooden beam act as a simple lever. Why are simple levers useful? They act as force multipliers. Stone block has weight of calculate moment about pivot reduced by weight. So perpendicular distance from weight to pivot is 0.4 meter, and we know that moment equal force times perpendicular distance, so it will be 12,000 times 0.4. Person in figure 2 exerts a force on beam, so beam is stationary. What is the size of moment of this force about the pivot? Should be equal to that produced by weight of stone. Large modern buildings are built using cranes to lift the weight. Compare advantage and disadvantage of crane with wooden beam. Crane has advantage of carrying higher loads and raising loads to higher heights, but it is expensive and needs specialists. Beam has advantage of being cheap and easy to operate, but has disadvantage of carrying smaller loads and raising it to smaller heights. Figure shows man-made power made to look like a tree. Tower contains 4 mobile phone transmitters. Transmitters emit electromagnetic waves. What type of electromagnetic wave? It is a transverse. Which type of electromagnetic would be microwave? Suggests why there is more than one transmitter on the tower to emit in all directions. Suggest two reasons why transmitters are not attached to a real tree, because it may cause damage to a tree and the tree may not be tall enough. Figure shows two different waves, A and B. Compared to B, A has a greater wavelength, and compared to A, B has greater frequency. Student carried out an investigation to determine elastic limit of spring. Give to safety precaution, put cushion under weights, wear safety goggles. Plain investigation the student could carry out to determine elastic limit of spring. Measure original length L node, add mass of 100 gram, calculate the force on spring, which is the weight of the 100 gram, which is 100 gram times G. Measure stretched length L, calculate extension L minus L node or extension ratio L minus L node over L node. Repeat previous steps until permanently deformed. Plot force against extension and you will find that elastic limit is where graph starts to curve. Will be a straight line at first, then after reaching elastic limit the graph will curve. Explain why it wasn't possible to repeat investigation of same spring, because it is permanently deformed or cannot return to its original shape. Student repeated investigation with different spring before limit of proportionality, spring stretched by 60 millimeter by force 3 Newton, calculate spring constant. So we know that force equal spring constant times extension. So spring constant equal force, which is 3 over extension, which is 60 millimeter. So the answer will be 50 Newton per meter. Figure shows 3-pin plug containing 13 ampere fuse. Describe how 13 ampere fuse protects an appliance. If current exceeds 13 ampere, it melts and opens circuit. Fuse is normally covered by a plastic cover that is easy to remove. Suggests why cover needs to be easy to remove to be easily replaced. Figure shows the steam iron that the plug is attached to. The steam iron converts liquid water into steam. Steam iron has different power settings. Current in heating element heats the metal plate. Steam iron is set to its lowest power and potential difference is given. Calculate current. So we know that V is equal to I times V. So I equals B over V, which is equal 3 ampere. Steam iron is then set to its maximum power off. Calculate maximum mass of water that can be converted in 1 minute by steam iron. And specific latent heat of vaporization is given. Give your answer in grams. So we know that power is equal to energy over time. So energy or Q is equal to power times time, and latent heat of vaporization is equal to thermal energy over mass. So mass equal to thermal energy or power times time over latent heat of vaporization. We can substitute times 60 here because he mentioned 1 minute, so should be multiplied by 60 to be converted to second, because here power is given by watt, which is joule per second, and latent heat is given in joule per kilogram. 2, 3, 5 zeros. So mass will be 0.066 kilogram, which is 66 gram. Explain why actual mass of steam produced will be less than maximum value calculated just now, because heat loss to surrounding like air and other parts of iron make the thermal energy calculated, not all of it goes to water. Figure shows an underground train station, train traveling at a velocity, train decelerates to stop, calculate time to stop, and deceleration is given. So we know that A equals delta V over T, so T will be equal to delta V, which is average resultant force acting on terrain as it decelerates is calculate mass. We know that force equal mass times acceleration. So mass will equal force, which is 912,000 kilogram. Force produced by trains brakes can be increased in an emergency. Figure 10 shows velocity time graph for train stopping in an emergency. Which feature of graph represents acceleration? It is a gradient, which is negative here. Explain why increasing braking force will decrease distance the train travels before stopping, because it increases deceleration and hence decreases time. Once again, A equals delta V over delta T. So as deceleration increases, time should be decreased and hence distance. Determine distance train travels during braking in emergency stop shown in figure 10. It will be the area under the VT graph. So the area of this triangle, which is half the base is here is 15, because we have this large square is 2, so the small square here is 1, so 14, here is 15, and the height, this square is 5, so the very small square here is 1, so after 20 we have 1, 2, 3, so 23 half times 15 times 23. This will equal. When stopping at stations, the brakes are not applied with the maximum possible force. Explain why. To avoid great deceleration on passengers, to avoid wearing on brakes by friction. Figure shows very old painting on a cave wall. Paint used contains a very small amount of radioactive isotope carbon-14. Age of painting can be determined by measuring a very small amount of radiation emitted by carbon-14. Give one reason why a sample of paint must be removed from the cave and tested in laboratory to decrease background radiation, because the sample will be away from these old stones. A very small sample of paint is removed. Give one advantage and one disadvantage of this. Advantage, it will make less damage to painting. Disadvantage, amount of radiation is difficult to measure. When a nucleus of carbon-14 decays, it emits beta particle. Explain why an atom of carbon-14 changes into different element when its nucleus decays, because neutron is converted to proton in the nucleus, so atomic number increases but atomic mass remains constant. Once the activity of paint sample is measured, figure 12 can be used to determine age of sample. The sample paint from image is 17,000 years old. Determine how many half-lives of carbon-14 have passed since the painting was painted on the cave wall. So as the age is 17,000 and he wants the half-lives, how many half-lives, so we need to know the half-life time, and half-life time can be determined from the graph by, if we look here, it is from 0 to 50, it takes 10 small squares, so each small square is 5. So after 200 by 1, 2, and here is 3, there is 8 small squares, and 8 times 5 would be 40, so this point here is 240. So half-life time would be the time taken to drop from 240 to the half of it, which is 120, which is above 100 by 4 small squares, 1, 2, 3, 4. So here is 120, and at this amount of activity will be the half-life time. To know the value of this half-life time, we need to know small square has what value. Here is 10 small squares represent 5,000, so 5,000 over 10, it will be 500. And our reading will be post the 5,000 by 1 square and half, so it will be 5,750. So half-life is 5,750. So 17,000, which is the age of image after 5,750, and sorry, if we divided 17,000 by 5,750, we will get number of half-life passed, which will be almost 3 half-lives. Okay. Oldest cave painting found is at least 35,000 years old. Explain why it's not possible to determine age of samples that is 35,000 years old using activity of carbon-14 in the sample. Use information from figure 12. Here is figure 12. If you look here, you will find that after 35,000 years, the activity is almost 0. So there will not be radioactive isotope to measure age from its activity. Isotope carbon-14 is made in Earth's atmosphere by radiation. To produce data in figure 12, scientists assume the percentage of carbon in atmosphere, that is carbon-14, is constant. Give to ways in which a human activity may have affected the amount of radiation in atmosphere in last 100 years. You can mention nuclear weapons, nuclear power stations, medical uses of radiation like X-ray radiation or gamma rays radiation in imaging and in therapy. Figure 13 shows a woman wearing prescription sunglasses in very bright light condition. Prescription sunglasses protect against the sun and also correct the effects of vision. Explain changes in woman's pupil when she first put on the sunglasses. It dilate, so it will dilate to allow more light in. Woman is long-sighted. She cannot read book in figure 13 without wearing prescription glasses. Explain how these glasses move her near point so she can read the book she is holding. You may include a diagram in your answer. As we learned with each other that long-sightedness people has a short eyeball, so rays are not focused on the retina but after the retina. So we use a convex lens that aids the eye lens to focus light on retina. Manufacturers of prescription glasses need to know the refractive index of material the lenses are made from. Table shows that a gathered from an investigation to determine refractive index of material a lens is made from. Light traveled from air into material. Angle of incidence in degree is given, and it requires to add other column headings. It will be certainly angle of refraction, and this will be the sign of either angle of incidence or angle of refraction. So use your calculator and calculate sine 10. It will be 0.17, so this is sine I, and certainly this will be sine R. Data in table 1 can be used to draw a graph from which refractive index can be determined. Explain how. So you will say that if we draw sine I on y-axis, sine R on x-axis, slope of a straight line will be the refractive index n. Wind speed affects efficiency of wind turbine. Figure shows power output and efficiency of wind turbine at different wind speeds. So x-axis is wind speeds and y-axis there are two y-axes. One represent power and one represent efficiency. At what range wind speed is the wind turbine most efficient? One turbine is most efficient at the efficiency of 0.6, which extends from 6 to 12 meters per second wind speed. Determine input power at wind speed of 5.3 meter per second. So we will find where is 5.3 meter per second wind speed. As we see here, it is 10 small squares represented by 2. So 2 over 10, it will give 0.2. So we expect 5.3 to be after the 4. Here is the half distance, so here is 5, and after 5 by 1, it will be 5.2, and half will be 5.3. So this line will meet the curve of efficiency at, here is 100 represented by 5 small squared, so 0.1 represented by 4 small square, so each small square would be 0.02. So after the 0.5 by 1 small square, it will be 0.52, and the line is just above the first 1 small square, so it is in the half of the second small square above 0.5, so it will be 0.53. On the other side, the other curve, the curve of power and wind speed 5.3 here meet the curve at 1.5 small squares above 2500. Here 0 to 500 represented by 5 small squares. So 500 over 5 gives 100 per small square. So above 2500 by 1.5 small square will be 2750. Okay, so here we got output power and efficiency, and needed is the input power. We know that efficiency is output power over input power. So input power will be the output, which is 2750 over 0.53. The answer will be 5000 and kilowatt, as the 2750 or the values taken from the y-axis is in kilowatt, and efficiency is certainly a ratio, so the input should be in kilowatts. Figure shows an AC generator connected to blades of wind turbine. Okay, and the potential difference against time. Explain how rotating blades produces potential difference in figure 16. When blades rotates, it rotates the magnet, and as the magnet rotates, magnetic field line cut by coil is changing with time. And this rate of change of magnetic field line cut by coil produces induced EMF that changes direction every half rotation of magnet. Imagine what we learned about the coil that rotates, that every half cycle or every half rotation, the polarity of the current in the outside circle or the voltage in the outside circle reverses. Okay, that's all. Thank you for watching. Share and subscribe, and we will see you later. Thank you.